Final video, dividing radicals. This definitely will take some practice in class. And I want you to read the first bullet up here, or I'll read it to you. In order for a radical expression to be simplified, no radicals can exist in the denominator. So you can't have radicals down below. Okay, so now that leads to a new property. We have one for division. The square root of a over b is equal to the square root of a over the square root of b. Notice you can break one radical fraction into the square root of the top over the square root of the bottom, or the radical of the top over the radical of the bottom. Okay, so in number one, we can make use of this property because I have a radical up here and I have a radical down here. And I can write this as giant square root sign, 20 over 2. 20 divided by 2 is 10. So I have the square root of 10. And notice there are no perfect squares other than one that go into 10. Okay, so that's kind of how it works. So let's take a look at number 2, and you'll see some changes here as we go. Okay, square root up here, square root down here. Students will always say, what do I do with the 4? Just write it out in front. Don't worry about it. Okay, write a giant square root sign because I'm putting them back together underneath one square root sign. 15 over 3. 15 divided by 3 is 5. 4 square root 5 is my answer. There are no more perfect squares other than one that go into 5. Next one. Yes, you can write it underneath one giant square root sign. Absolutely, you can do it the same way you did before. However, remember something about canceling? I have the square root of 3 over the square root of 3. Bing, bing. 7's my answer. If you put it underneath one giant square root sign, you just get 3 over 3, which is 1, and the square root of 1 is 1, right? So do it a little faster. Do it that way. Okay, now things will change in these next two. Okay, notice in number 4, the top does not have a square root like the other ones that I just showed you did. There's no square root sign in the top. To be able to use this property up here, you have to have a square root sign in the top. So how do we do it? Well, you have to do something different. And what it's called is, I'm going to squeeze the phrase right here. It's called rationalizing the denominator. Okay, here's what I mean by rationalizing the denominator. We're going to make use of something that we learned in the last video. I have 5 over the square root of 2. Remember, our rule is we can't have square roots down below. So what I'm going to do is I'm going to multiply top and bottom by the square root of 2. Now, first thing, it's legal, right? If you do the same thing to the top and the bottom, that's the first thing. Second thing, do you remember from the previous video what happened when we did the square root of a number times the square root of itself? Well, here's what happened. On the top, I get 5 square root of 2. Down below, the square root of 2 times the square root of 2 is just plain old 2. And some of you might be thinking, well, wait a minute. Isn't the square root of 2 times the square root of 2 the square root of 4? Yes. And what's the square root of 4? Well, that's just 2. Okay, square root of a number times the square root of itself is that number. Okay, there's our final answer. Yes, it's okay to have a fraction as your answer. Last one. Square root of 7 over square root of 2. Now, remember what I said before. We do have a square root on the top and the bottom, unlike this previous question. However, 2 doesn't go into 7 evenly, and you have to get rid of square roots down below. Well, how do we do it? Rationalize the denominator again. Square root of 2 times square root of 2. Do the same thing to the top as the bottom. On top, I get 2 times the square root of 7 times square root of 2. Now I'm going to use that first property, and I get the square root of 14 because they both have square roots over it. I did that kind of quick. I hope I didn't lose you on where square root of 14 came from. Now down below, the square root of 2 times square root of 2, just regular old 2. These cancel. Are there any perfect squares that go into 14? The answer is no, other than 1. So my final answer is the square root of 14. We'll definitely practice this because those last two are kind of tricky. The phrase that we use is rationalizing the denominator. Thanks for listening.